Welcome to EDU World Space.
This is chapter 21, problem number 14. We have two small non-conducting spheres. We're given the addition of the charges of these two spheres, 90 microcoulomb. So let's convert that to coulombs times, right, 90 times 10 to the power negative 6 coulombs it's going to be. Now in part A, we're asked if the separation distance between these two charges is 1.16 meters and the magnitude of the force is 12 newtons and is repulsive. That's an important part. What are Q1 and Q2? So repulsive means Q1 and Q2, they have the same sign, right? Either both of them are positive or negative. So let's remember the Coulomb's law, Q1 over Q2 over R squared. Let's separate unknowns on one side of the equation and the knowns on the other. So Q1 times Q2 is going to be equal to FR squared over K using the Coulomb's law. And if you plug in the numbers, 12 newtons times 1.16 meters squared over 8.99 times 10 to the power of 9 Newton meters squared per Coulomb squared, we get 1.8 times 10 to the power of negative 9 as a product of Q1 and Q2. Now we also know Q1 plus Q2, right? So we have two equations and two unknowns, and we should be able to solve for them, right? Q1 and Q2 is 90 times 10 to the power of negative 6 coulombs. Q1 times Q2 is 1.8 times 10 to the power of negative 9. And like I said, this is there are two coupled equations here. So there are too many ways to solve this. Eventually we're going to get to a quadratic equation. There's no escape from that. So, what I would do, I would isolate one of the unknowns from one equation and plug it in the other. And that's exactly what I'm going to do here. So, I am going to write down Q1, for instance, using the first equation. Q1 equals then 90 times 10 to the power negative 6 minus Q2, right? And then I'm going to plug this in the second equation. So 90 times 10 to the power negative 6 minus Q2 times Q2 is going to give me 1.8 times 10 to the power negative 9. So if we distribute this, so 90 times 10 to the power negative 6 Q2, let me put the parentheses here, okay, minus Q2 squared equals 1.8 times 10 to the power negative 9. Again, recognize this is a quadratic equation, the second order, the first order. But let me put it arrange it in a way that we can recognize that it's a quadratic equation. So if we take Q2 to the other side, it changes sign, right? And also the coefficient of Q2 also changes sign, so it's going to be negative of 90 times 10 to the power negative 6 Q2 plus 1.8 times 10 to the power negative 9 equals 0. Now you can see it easily, right? It's a quadratic equation. A in the quadratic formula, if you remember, there are two solutions to these type of equations. Q1, Q2, assuming that we have we're going to have two solutions, right? Negative B, coefficient B, plus and minus, right? They're corresponding to separate solutions. B squared minus 4AC, 4 times AC times C over 2A. Now, let's see what A is here. In our case, it's 1. B is negative 90 times 10 to the power negative 6. And C is 1.8 times 10 to the power negative 9. Now, then, if we apply the quadratic equation formula, Q2 equals negative B, right? Negative B, negative, it gives us positive. So this is 90 times 10 to the power negative 6. Plus, let's take the plus. You're going to see that you get the same answer even if you take the negative. And then we have square root of B squared. So negative 90 times 10 to the power negative 6 squared minus 4 times 1, A is 1, times C, 1.8 times 10 to the power negative 9 over 2 times 1 is 2. So from here, Q2 is going to be found to be 60 times 10 to the power negative 6 coulombs. So now, since we know Q2, we can easily, let's use the first equation in order to be able to calculate the, well, actually, it's better. It's here, right? We had isolated this. Q1 then equals to 90 times 10 to the power of negative 6 minus 60 times 10 to the power of negative 6. So it is 30 times 10 to the power of negative 6 coulomb. As you can see, they have the same sign. So that's good. Now, in part B of the problem, we're given this time the force as an attractive force. That's the only difference in part B. So now the magnitude is that everything is the same, only that the force is attractive, which means they have Q1 and Q2 have opposite signs, right? So only change that we're going to make, I'm going to follow pretty much the same recipe. The only difference now, because the force is negative, remember our Q1 times Q2 equals F R squared over K. This time, it's not going to be equal to something positive. It's going to be, because of the force magnitude being negative, because they have opposite signs, negative 1.8 times 10 to the power of negative 9 is what we're going to have as Q1 times Q2. Still, Q1 plus Q2 is the same, 90 times 10 to the power of negative 6 coulombs, right? So we're going to follow pretty much the same recipe, then isolate, let's say, Q1 out of here. Q1 equals 90 times 10 to the power of negative 6 minus Q2, and then put it in the first equation. So 90 times 10 to the power of negative 6 minus Q2 times Q2 equals negative 1.8 times 10 to the power of negative 9. Again, 90 times 10 to the power of negative 6 Q2 minus Q2 squared equals negative 1.8 times 10 to the power of negative 9. Again, we're facing a quadratic equation. So Q2 squared minus 90 times 10 to the power of negative 6 Q2 minus 1.8, that's the difference, times 10 to the power of negative 9 equals 0. So now, again, A is the same. A is 1. B is the same, negative 90 times 10 to the power of negative 6. But C is now negative, and that's going to change our answers, right? Again, using the quadratic equation, then Q2 is going to be equal to 90 times 10 to the power of negative 6. Just use the positive value, square root of, again, negative 90 times 10 to the power of negative 6 squared minus 4, negative 1.8 times 10 to the power of negative 9 this time. Right? The square root goes everywhere, over 2. So from here, Q2 is going to be 107 times 10 to the power of negative 6 coulombs. And again, Q1 equals 90 times 10 to the power of negative 6 minus 107 times 10 to the power of negative 6 now. Then Q1 is going to be negative 17 times 10 to the power of negative 6 coulombs. As you can see, the signs are opposite. So everything is great, which means the magnitude of the force is negative, which means there is an attraction going on.